Hello viewers, welcome back to video tutorial on AgentGrid, and this is the second part of the video series where in the first part of the video we were showing you how to run a simple workflow or a sequential workflow using AgentGrid SDK, and in this video we'll talk about the multi-level or a nested workflow with AgentGrid SDK. So in this walkthrough, we'll show you how to build an orchestrator multi-level or a nested workflows using AgentGrid SDK and AgentGrid workflow engine. And as usual, we'll take an example. The example here is a loan fraud investigation using workflows of AgentGrid, where a request passes through a series of agents and a router and also a sub workflows. So you will have multiple workflows here. One is main workflow and one other is a sub workflow. So we'll show you that in coming section. So workflow basically helps in binding agent flow with kind of a graph style or a router style, where graph style it could be an cyclic or a cyclic kind of a style you can implement, and also a router style execution where router acts like a orchestrator. So allowing basically this allows us doing a modular working path for the data. So the diagram structure, it is pretty much similar to what we have shown in the previous video, where we have three folders: main, nodes, spec, and deploy run. Let me just show you that. So this is the main folder where we have agent LLM, agents SDK, and utils. So this files, this agent LLM is for basically files needed for communicating to our LLMs deployed in either AIOS or any other third party like Gemini or ChatGPT. Agent SDK is all the files related to housekeeping stuffs of agent SDK. So simple workflow we have defined, we have already showed you, and we have a multi-level workflow. And also in this folder we have a bash file which is for building the Docker containers required for the running either simple workflow and multi-level workflow. So this multi-level workflow and push, what it does is basically builds the Docker containers and pushes to the registry. And also we have entry point and Docker files here. In the entry point, for a single entry point.sh file is available, which will be branching according to the environment we passed. So for different containers, so different Python program will be called from this entry point.sh. So let me directly go to the multi-level workflow. We have a deploy and run folder, nodes folder, and spec folder. Three folders are present here. So this node folder will contain basically all the source codes, basically py files. Let's say we have a router agent, we have a financial profile agent, market risk agent, collateral evaluator agent, transaction history agent, identification verification agent, fraud score agent, and final is a load decision agent. So these are the py files available in this folder, and we have a spec file which is like contains the files needed for registration of these agents. The registration is done through API with the help of the JSON files. So we have all the JSON files required by all the agents are present in the spec file. Along with that, we have a registering file like bash scripts, which will take this JSON files and registering to an endpoint. At the same time, we have a deploying files, removing of the deployed agents and unregistering of the agents. All the files are present in the spec folder. And the deploy and run folder, basically it contains the workflow files and sub workflow files, and also we have an streamlit app, and also we have bash scripts for sending the input to the inference. So before going into the code, so let's see the diagram of flow diagram of multi-level workflow. Basically we have an for this use case we have an router agent here. This is the agent which will take care of basically orchestrating and talking to each and every agents in a sequential flow. So first, the router agent, as soon as it gets the input, it will call an financial profile agent. What it does is basically given an input, it will try to identify key points from it, and it will try to create a profile for the user. And once that output comes from that agent, the next agent is a step 2 here, which is happening in parallel. So again, it will give the input to the these two agents, market risk agent and collateral evaluator agent. Basically, these agents run in a in parallel manner. Basically the input goes at the same time for both of the agents, and these agents are responsible for identifying the market risk involved in the loan application. And also this agent will try to evaluate the collaterals, like the user might have given some buildings of his own or a property of his own, So what is the collateral? So whether it's sufficient or not, so kind of evaluation is done by this agent. So once all these three agent outputs are ready, then a router will take a decision. Basically, it is an fraud detection. It will evaluate whether a fraud might be available or not. Not in a it's on a high level, not on a deep level. So if fraud is detected, it will goes to one flow, and if fraud is not detected, it goes to one other flow. So I'll show you example with both of this flow. So if fraud is not detected, so it will directly fraud detected, and it will go to the one agent, which is known as loan decision agent, which will take a final decision, and that's the output will receive the output. If fraud is signal is detected, so a slight fraud might be available. So it's in such cases, it will go to an sub workflow, and in this sub workflow, we have three agents. So transaction history agent, identity verification agent, and fraud score agent. So basically, they will act upon each previous data, and they will come up with some data that is needed by the loan decision agent to take a decision. So here, as you can see, there is a main workflow. The whole router thing is a main workflow. The router is a which is doing a switching between the agents, which agent it has to go, and things like that. It is taking decisions. And this is the second workflow, sub workflow. So let's get into the course. So first, let me show you the financial profile agent. So the financial profile agent. So this is basically an mapping. Yeah, let me go to the agent workflow first. So here we have a workflows. Instead of going to code, I'll just explain you the workflow specs files. So we have a workflow spec file here. It's the main workflow spec file, specification file. So we have in the header and body, in the header section, we have a workflow ID. Workflow loan risk assessment is the name that we have given to this particular workflow. 1.00 and production. So all these three commands URI, metadata, some data related to this workflow. And in the body section, we have a notes and a graph section. And in the notes, we have all the notes that is going to be part of this particular workflow. All the notes are available, right? Whatever in the main notes in the workflow are defined here. So I'll just expand all the workflows. So all the nodes of the workflow. So first we have a router agent. So it has a subject ID. It is coming from this particular ID. So this is nothing but the subject ID of the agent. So whenever we register agent, it should have a subject ID. So that ID is mentioned here. And this is the node ID. So this node ID is a string that is a part of this particular. It's a string. What it just gives a unique name in this particular file. So we can use, if you want to use this router anywhere for any purpose, like say input output mapping or anything, so you can use this particular node ID. So we have given a name as a my router agent. So this is the subject ID. Similar to that, we have an financial profile agent, and I'm giving a name as my financial profile agent. My risk agent, so market risk agent, basically it will evaluate the market risk. And I have an collateral evaluatory agent, so when they will run in parallel. And next is a if you see, right, all are type of agent. So next is a one specific thing which has a type as a workflow. So this is what is the sub workflow. So the ID here is a complete URI of the workflow that I'm going to call. So this workflow fraud investigation 1.0.0 production is the subject ID of the workflow. So that's what we have it here with the work underscore spec hyphen nested. So it's like a small sub workflow. So this workflow fraud investigation 100 production is the workflow ID. So that's what I'm referencing here, workflow. The type is workflow and that URI of the workflow, and I'm giving one name to it, my fraud investigation workflow. And the final agent is a my loan decision agent. So this forms the complete all the agents and work sub workflows of the this particular main workflow. And I have type here the graph. In the simple workflow, we used to mention who is the input, who is the output. So that kind of a graph we used to mention here. But here I'm saying it as a type is dynamic, and a node ID is a my router agent. So basically, my router, the input, as soon as we send the input, right, it goes to this my router agent, and my router agent will take care of routing this wherever it wants to route. So all the routing logic is defined in this my router agent. it is not in the direct complete, it's not in the graph of the spec file. So this is about the main workflow. So let's go to the sub workflow now. So in the sub workflow also we have three agents. One is a workflow transaction history, workflow identity verification, and workflow fraud score evaluation agent. And so there we have kept a graph. There is no dynamic here because I wanted data to flow from one to one as a simple workflow. So here my transaction history gives the output to my identity verification, and my identity verification agent will give the output to my fraud score agent, and my fraud score agent will send the output back to the router, because the router is the main guy which will receive input output from all the agents. So it will come back to the router here. So this is the two workflows. So let me just go back to the code now. First is a financial profile agent. So this is just for we wanted some data like what is the subject ID and what is the node ID. So if for that mapping I have kept this file here, this key, the variable here, node ID mapping. So in the financial profile agent, there is one the coding structure remains same for all the files except the router agent. So I'll explain one of the file, and I'll show you the signatures of all other agent files. So rest of the code will remain same. So I'll not show you that. So here we have one signature here. As we use a DSPy, we are creating a signature here. You are a senior credit analyst at a commercial bank. Analyze the loan application text and extract the structured financial profile of the application. Pay close attention to any inconsistencies or signals that might indicate a representation of or a fraud. So respond only with valid JSON. So this is the we are giving in some text here, and we wanted this agent to extract this kind of a data from this input. So we want application name, annual income, total debt, credit score, DTI ratio, employment status, credit worthiness, profile summary, fraud signal. This kind of outputs we wanted it from this particular agent. So what we give is the input, which is an application text, and a financial profile, which is having a JSON structure of this sort. So we have an module here which takes this signature as an input, and it does a predict operation. And we have this module has a for function. So whenever you call this for function, right? So whenever we call this class with dot forward, so it will basically do the inference. And we have a payload processor here. So this function, this class will vary from each of the agents. Basically, this is to parse the incoming request. And we have a context manager to give the context for a LLM for this particular module. So we have an main class, agent class, the financial profile agent. It has some iterate function. It has a get muxer, on preprocess and on data function. So there is no muxer required for our demo right now. That's why we have written it as none. So this function is required for sure. So 4 functions are very must. So init, get muxer, on preprocess, and on data. So on preprocess we are not doing much, and in on data function only we are doing the actual task of this particular agent. So for what we'll do, given an input, we'll break that input and extract the content that we needed for this particular agent. We are creating in a registry variable, and I'm just dumping all the data required by the registry if in case this pod is lost or something, right? So we can store this registry. Right now I'm not storing it anywhere, so we can store this content of this registry somewhere, so that we can, even if the pod dies because of some reason, as soon as it comes back online, because the pod can run in any of the node, so we can pull that content. So right now for that sake I just kept this variable, but I'm not using it, this content of this variable right now. So the incoming request, whatever the data we are getting, right, I'm just dumping it into his human intervention system. The reason for that is I'm having a Streamlit sort of a dashboard. So this is the dashboard. Let me just clean up the old data. So I have a Streamlit application where I will be showing the input and output for each of the agents. Yeah. So this function will dump the data, the incoming request, and who is the input and who is the output. All those details it will be dumping it. This particular function log to his function is available here, and we are just using the his client here. His client is a human intervention system. So that we are creating in the init class. So init function, we were creating that his client, using that his client. So all those his clients are part of a AgentGrid SDK. So you can see here his client is imported in agents SDK.co.his. So once input is dumped and we are sending the one input is dumped to the his dashboard, then we are doing an execute worker. What it does is the execute worker function is present here. Execute worker, it does the cell.model context get context. So basically it will tell the DSP which model to choose, and then it does an module.forward operation. So once the output is received, like once the output, we collect the output, so from that we'll extract the financial profile key and we'll send it to a passing logic, and once passed we'll send that output to the his module. So the previous thing, we logged the input, and now we are logging the output. So target ID, we are giving my router agent, basically it's the who is the next agent. So that's what this target ID is. So this is the node ID basically, but I'm converting it into the agent subject ID later on, and then we are returning that result. So we are not exactly saying to whom to the output should go. We are simply returning the result. So this only that who is the next agent, this is only needed for the log to his, not required for anywhere else. So even if this log to his is not required, right? So even if it is not needed, we can remove it. So but for the demo sake, I have kept this log to his. So in that place only I have used the who is the next agent. Apart from that, I'm not saying who is the next agent. I'm simply returning the agent output. So the whom it has to go, that will taken care by the router agent itself. So we have returned the output here with the job output and job output metadata, and we have created working as prod signals and the passed output we are sending in these two variables. So this is the financial profile agent. And next is the two parallel agents. So is the financial profile agent, it will send the output back to the router, and then router will take again call this market risk agent and collateral evaluator agent in parallel. So let me just show you the collateral evaluator agent. So it has two signatures. One is for extraction of the content. So it will get an application text and it will try to extract two items from it. Requested loan amount, we can do a regex operation as well. So what is the loan amount requested, and what is the market value of the collateral? Let's say this user is giving his residential property. So what is the residential properties estimate? So we use that extracted data from it, to like the requested loan amount and estimated market value, and we'll be using it to calculate certain things. So next signature is a collateral evaluator signature. So you are a collateral evaluation specialist at commercial bank, evaluate the collateral offered to in the loan, check for overvaluation or unverified assets or anything inconsistent with the applicant's financial profile, flag any signals that suggest the collateral may be a fraudulent or a misrepresented. Critical instructions are given. So basically has to create an LTV. What is LTV? Basically the requested loan amount divided by the market value of the collateral. So that will give the loan to value ratio. So if that ratio is around somewhere around 70 to 80, that is 0.7 to 0.8, it means they're okay, typically okay. And if it is greater than 1, then they are extremely risky. So with that knowledge, we are asking it to produce this kind of data. So we'll provide the application text to it, financial profile to it, and also we'll provide the LTV ratio that we calculate from this particular extracted data, and it has to collect the collateral evaluation. The JSON structure is here. So rest all remains same. So only thing is we have a module here, and it does for in the forward operation we have a content for LTV ratio calculation as well. So that is the only difference. Apart from that, there's no other difference. So rest remains the same. So I'll not explain the code again. So at the end, it will return the result. It will not tell to whom it is returning. So only thing we are mentioning who is the next agent is the log to his. So let me close the workflow. Next is a market risk agent. So market risk agent is basically try to evaluate the risk for the given loan, whether it is a commercial loan, whether it's a personal loan, or what sort of loan the user is asking. So it will basically try to analyze the market risk. So we don't have an direct data related to the current scenario, but it is LLM is trying to predict something. So you are a macroeconomic risk analyst, commercial line, given a loan application and the applicant's financial profile. Assess the macro market condition and sector specific risks relevant to the loan. Note any market signals that might be inconsistent with the applicant's stated financial positions, potential fraud indicators. So we are asking it to give again a sort of a JSON where we are giving an application text, financial profile data is given, and a market risk assessment it has to give. So it basically try to assess the market for the given loan. So nothing fancy here. Rest remains the pretty much same. So now, these three agents are over. So I'll explain the router agent now, as that is having very significant amount of work, as that is the guy which will do a routing operation for us. So that's why, as the graph here is a dynamic, and my router agent, which is the Tippet, this particular agent is the main code where it will do the orchestration. So let me just go to the router agent. So router agent, so we have an signature here. So this signature is used during analyzing the at this particular at this point of time at step 3 we want to analyze whether there's a fraud or not. So in such that case we wanted a signature. So that is the signature. You are a financial fraud specialist. You will receive a output from financial profile analyst, market risk and collateral evaluation for a loan application. Your job is to determine whether there are any fraud signals that warrant a deep fraud investigation. So the fraud signal includes but are not limited to, so some conditions are given. So it has to detect whether there is a fraud signal or not, and the reasoning it has to give. So the inputs are financial data, market data, and collateral data. It has to give the fraud signal in this kind of a JSON with 3 keys. So we have a module here which does the forward operation, payload processor, context manager, and we have a main router agent. So the router agent, the main thing is a on data function. Rest remains the pretty much same. So you can see here, like I'm trying to extract the output coming out of other agents, because this agent gets the input first input, and also it passes on the input to other agents, and it only receives the output from other agents. So in that I have some keys like history key, outputs key. So history key, like what all agents are covered till now, what all agents are done with the data. I mean data analysis or output is done till now. That is a history, which is an array. We have an output of all the agents are present here. Initial input, original input, which is a text input, and last executed batch. So the last executed is basically a single content, single object, where it tells about who is the last agent executed and what is its last output. Whereas this last executed batch is basically, like, say if you are doing some parallel operations here, we are doing a parallel operation. So since we are sending the input to 2 agents in parallel, uh, the agent SDK will take care of collecting the output in parallel. And let's say this takes 5 seconds, this takes 6 seconds. So the agent SDK will wait for the 6 seconds to come, and once 6 seconds is over, the agent of this, which was getting over at 5 seconds, and this got over at 6 seconds. So at the end of 6 seconds, both the outputs are collected and will be given to the router agent. So both the output we wanted, so that's what we call it as a last executed batch. So it's basically an array. So if this key is not available, we'll take this key. If this key is available, we'll give that precedence to that key. So if it is a batch, which is an array, from that array we are trying to extract a node ID. We call it as last node. If it is not this, if this variable is not there, only this variable is there, I'm trying to extract last node as an one single node ID only. I'll try to extract. So if last node ID is not there, basically again I'm doing an input output I'm putting into the dashboard. So if there is no last node, meaning it's the first input, right? So I'm dumping the input to the his, which is nothing but last node is empty, history is empty, initial input I'm dumping. This is the only variable that I want. If it is not an initial node, if it is an intermediate results, right? So I will tell who is the last node's history, last executed batch output, and last executed output as well. I'll try to log it in the his human intervention system. So now I'm doing I'm calling a function known as root. That function is present here. So what this function will do is it will take care of the whole control, like where the input has to, I mean, who is the next agent, all those logics are put in this root function. So let's say the last root is not there, then it is the first time input is coming. So we have to call the financial profile agent. So when there is no last root, this is the first agent I need to call. So that's why this condition will take care. And this function will return only the array of node IDs, array of objects. And in that object, we have a node ID key and an input key. So I'll just explain when we return this array, where this root function has to return this array wherever it wants to return. So whenever it returns an array of objects, so it will basically we'll try to extract. So this is the next steps is the result of this particular function. From this, we'll try to extract the node IDs of the agent, and for that agent, we are trying to dump the output in his, and also we'll return the output to that particular agent. We are passing the next steps data metadata is the next steps, whatever the object we get, right, we'll pass that output itself to the next steps, and next node details are present here in this two case. So this agent will take care of talking to those agents. So next, let's say for the first time we are sending only the financial profile and the input also, whatever we need to pass on to the financial profile, right, that we are sending here. So the whole dictionary will go to as the output metadata, and the next steps. Next steps is this particular result. Next nodes is who all are next node. So this key is very important for the router to pass on to the AgentGrid SDK, and AgentGrid SDK will see who is the next node, and for that node, what input needs to be passed on. It will take from here. So next is a let's say the step 2. So basically parallel calling now. So if node financial profile in last node, so meaning whenever it returns the first node returns the output, right, the first financial node returns the output, it comes to router, and router sees that there is an history variable, there is a output content, there is a last executed as well, and last executed batch also will be present. So if in case that the last node is the node financial profile is the present in last node, then the last node executed was a financial node, and now I need to run two things in parallel. So what it will do is it will simply return who is the next agent that it needs to call. So the next agent are market risk agent and a collateral agent, and I'm passing it in array. It means those agents has to be called in parallel. So once the step 2 is over, now next is step 3. So basically in the step 3, I'm checking whether I have a market risk output and a node collateral output. If those outputs are available with me, then I'll call a route to parallel function, or else I'll not call. Basically, the AgentGrid SDK will try to collect the output of these two. We are not going to collect. It will only collect because we have sent two as an content of this array, right? So it will parallelly send the input and parallelly collect the output. And once it collects the output, it will come here. So definitely this only has to execute. So once this is true, it will call the root after parallel function. And what this function does is, so we have it is creating financial the output of each previous agent. It will try to collect financial profile agent, market risk agent, and collateral evaluator agent, and then it does an LLM call. So what this LLM call is basically about whether there is a fraud or not, with the help of the signature that we have at the top. So it will call that, and it will try to extract and parse the content from it. And then if there is a fraud detected signal, fraud signal detected output is there, right, and signals and reasoning. So it will try to club the output now. It will create a final output from this particular the output of this particular LLM. And then if fraud is detected, then it will send who is the next agent. If fraud is not detected, who is the next agent. So if fraud is not detected, it is a loan decision agent. As you can see, if fraud is not detected, it will directly go to the loan decision agent. And if fraud is detected, it will go to the workflow. So if fraud is detected, it will go to node fraud investigation. So the node fraud investigation is nothing but my fraud investigation workflow. So basically it will send the input to the workflow itself. So workflow will, since we are sending the workflow as a node ID, the LLM will understand what is the type of the node. So as we mentioned, it has an we have mentioned it as a workflow, right? So it will understand what is this workflow and who is the input of this workflow. It will try to understand that, and it will call that particular, it will pass on this input to the first content. So the input of that workflow, it will send that to the input node. So this is in the calling the workflow, the sub workflow. So once sub workflow is done, let's say after fraud investigation, so node fraud investigation in last node, then a fraud investigation has been called, and at the end we have to send it to a loan decision agent only. So and if fraud investigation route is called, then it will try to send the data to load decision agent, and it will try to create the input for it. What is the input? The financial profile, market risk, collateral, and the fraud investigation output. The fraud investigation output is the output of the sub workflow. So it will create that input and it will send to the node loan decision agent. And if there is no fraud investigation, then it means it is directly to the node loan decision. So we have not gone to that sub workflow. So it will simply return nothing. So because the final output is coming from the node loan decision, and we don't have to call any other agent, is what the meaning is. So with this, we have finished the whole flow of the router. So in the sub workflow, like we have 3 agents which are like doing one after the other. So the first agent is a transaction history. So let me just show you the transaction history agent. So transaction history agent, it has again one signature. It is trying to extract the transaction histories of the user. Um, Apart from that, nothing else it does. So we are expecting some key outputs. So transaction analysis, large cap deposits, income consistency, unusual patterns, high risk. Basically, all this requires the input of your bank statement, but we are not providing it, but we are asking LLM to do some predictions. So this is the transaction history, and next agent is a identity verification. So right now you are an identity fraud specialist at commercial bank for fraud prevention unit. Cross-check the applicant's entry information for consistency and signs of fraud. Look for mismatch employer details, suspicious addresses. Those details are not with me right now, but if in case we have it, right, we can provide it. So for time being, we are just filling the data. So we are not doing a true identity verification or a true transaction history verification. And the fraud score verification, it basically gives in a score to the fraud and fraud verdict. So we can basically train how to estimate the fraud score, right? If in case we have an real-time data with us, like to how to give a good score, I mean a fraud score. If you have a data, we can train it, but right now I don't have it. I'm just asking LLM to provide some number estimation based on the given input. So it will provide a fraud score and a verdict. It will give and contributing factors for this fraud score, and recommendation action and fraud summary. It will give details. So this will come back to as a output to the router agent, and final agent is a loan decision agent. And loan decision agent, you are a senior loan underwriter at commercial bank making a final leading decision. You will receive a risk desire or loan applicant, including their financial profile, market risk, and collateral evaluation. So you need to provide it as an approved, conditional, or rejected state you have to give, and also along with the complete output structure we want in this format. So we are providing all the inputs required, and we wanted a output. So this is the one signature where it is not having an fraud detection content. So if a fraud detection content is there, right, the sub workflows output is there, then we are using a separate signature where I'm introducing fraud investigation data as well. So fraud signal data also is present here. Whereas for this signature, it is not available. So basically this agent will decide which to you choose based on the input that it receives. So apart from that, we don't have basically it is doing an if and else condition here. If fraud investigation data is present and fraud signals are present, it does the one function decider fraud or a decider base. Decider base is basically calls the this signature, the first signature, and then it returns the output back to the router, and router sends this output to the user. So this is the whole of the code. All the routers, all the codes are explained. So now let us go to the demo part. So demo as usual, we need to build and register the agents. So let me register the agent. What register agent will do is it will go to the spec folder, and whatever the spec files are there, right? So it will just dump this contents into the DB. So that is the registration. We have a registration endpoint, and to that endpoint, it will provide all the JSON files and it will dump that data. So that is the registration. Let me just run the registration. So yeah, before that, it got the content. So I'm doing a post operation, API subjects, and I'm giving the JSON files to that endpoint. So this is the registration file. So let me do a registration. Yes, it has done the registration. So registration is simply dumping the data related to the agents into the DB. So let me build my containers. So now all the containers are built for this particular workflow. So all the agents are built and pushed to my registry, and we have to deploy now, because containers are created, agents are registered. Let me deploy the agent. So deploying basically. So let me deploy the agents. So as soon as deploy the agent, I'm getting a success true. So let me just run this cell. So it will tell you the agents created successfully. So these are my agents workflow, whatever the agent workflow you are seeing here, right? So the current agents which started few seconds back. So ignore these agents. They are some demo agents. So in the deploy, you have an endpoint again, post operation / API deploy agent, and you require an deployer. So deployer, the content that you need to give is what is the subject ID and the location details. In a location detail, you need to provide these meshes and delegate API URLs. These are needed for communications, and the instant detail, how many instances of a agent you want. So those kind of details you need to mention in the content that you post for the deployer for agent deploying. So I am doing this for all the agents. So let me deploy the agents. So agents are already deployed, and now next is a registration of a workflow. Let me do the registration me. So it has registered the workflows. Basically, what registration does is it takes this specs file and dumps it into again API. So API workflows is the API. It dumps those workflow specs, the specs that we have just seen. And once registration is over, we need to deploy those spec file, the main workflow. So in our case, the main workflow is this workflow spec, which is having a name of workflow one risk assessment. So that we need to deploy. So that's what I'm doing, deployment here. API deploy workflow deployer, and I need to give the workflow ID, the workflow known risk assessment, and the URI. So these two are important parameters, and also deployment names. This is basically taken by the K8s for creating a name required for the deployment. So let me just deploy the workflow now. Yes, we have deployed the workflow. So basically it creates a pod which will take care of, this is the pod that we have just now created. This will take care of basically all the communication pass on, like when to receive input, where to receive input, whom to go, all those details. This workflow will take care, and it will take care of passing on those data required by sub agents, or whatever the agents are there, right? So this pod would take care of passing those inputs to those agents and collecting the output and sending it back to whomsoever it is required. So this pod will take care of the workflow life cycle. And this is the URL. So this is the URL of the pod. Basically, this URL we need to use. This URL we need to collect and use for sending the input and output. And so this is the for now. And let me run a Streamlit app. So we have a Streamlit app I have already run it. It's the Streamlit app. So I don't have to run it. Yes, this is a Streamlit app. We have to risk assessment, utility level workflow, and the sub workflow. So in the sub workflow, we have 3 agents, and here we have 4 agents. That is the workflow. It's not required. So we have 4 agents in the main workflow. So now let me run the workflow input. So the workflow input. So this is the workflow input. So right now, first thing is I'm accepting the testing. So there is two inputs here. One is a success, and one is a fraud investigation. So this will check there is this input will help in not going to the it will go to this particular flow where fraud will not be detected, and it will directly go to the loan decisions. Let me run that first. So here what I'm mentioning is basically I have to collect that URL that we were talking about, right? So this is the URL. This is the URL we need to collect. So this, it will basically collect those URLs of that particular the workflow, and with that workflow it will send the API execute file to, it will send the input. So text is the key and input is the content that we need to pass on. So in the text input you have some basically application John Smith, loan amount requested is a 850K, and Copus is commercial property purchase, and annual income of this particular user is 180K, and self-employed consulting credit score is 720, total existing debt is 320. Okay, and collateral, so he wants to give a residential property which is values 1000K. So 850K, so it's like residential property is more than a loan amount. So it should be, by looking at it, it should be fine. So the loan is approved for this particular person. So employment, self-employed 3 years, previously unemployed for 2 years. Recent activity, there are 3 large cash deposits totaling to 95K in last 6 days. So these are some details about the user, and let us see how this comes. So hitting the input, it is going to multiple agents. Let me just refresh the dashboard here. So it has go to collateral agent now. From collateral agent you go to the router agent, and it will directly goes to workflow decision agent, and workflow decision agent has returned back. So you can see the fraud investigation, there is no input at all. So this is the first loop. So let me just show you the output. So this is the input coming to the router. So input to the agent, router incoming. So this is the text that we have sent from our bash script, and this is the output. So up to the same text it is passing, and who is the next agent? It is a financial profile agent. So this is the second is a financial profile agent. So for financial profile agent, input is same what we have sent earlier from the router agent, and the output from here is, it will provide some details like what is application name. From this text it will try to extract these details: annual income, total debt, credit score, DTI ratio, employment status, credential worthiness, profile summary, fraud signals, anything are presenting directly in the incoming text itself. Is there any fraud details are present on? So those kind of details are present in the agent workflow. Sorry, the profile generator agent. So now it will send the output to agent risk router. So the risk router will receive the input. So loan risk router. So incoming task. So last node, it has a 4 things, the 4 keys: last node, history, last executed, and last executed batch. Batch will have an array of items. Again, the last executed has a directive 1 item. So since this will be received from only the financial agent, right? So the last executed batch has only 1 array content. So it has an already output, and output has all these details which is same as this content here. So annual income is this much. So whatever the financial profile I generated, right, it has come here. So that is the incoming for the router now, and it will send that output to 2 more agents. The 2 agents are one is a market risk agent, one is a collateral agent. So for market risk agent, we are sending the same output of financial profile. So the text and the financial, the original input and the financial profile output is sent to the market risk agent, and same output is sent to the collateral evaluator agent as well. And let us see the market risk agent. So market risk agent has received the input, it's the text and the financial profile, and it has generated the output. So the output contains the market conditions, sector, it's a commercial property, favorable, medium risk, and a stable sector, employment trend, stable, macro risks. So it has evaluated some data. So with X knowledge, whatever the knowledge it has trained with, it has evaluated some data. and that output will be sent back to the router. So next agent is router again. So it has sent that details, all the details it has calculated. Similarly, in parallel, the input has gone to the collateral evaluator output. So that was the input, and it has collected the output, and that output is residential property collateral type, stated value 1000 K, and estimated market value 800 K. LTV ratio, basically it's divided by this, so it's supposed to be 850K. Yeah, that's why it has calculated ratio properly, but this number has missed. So liquidity is high, verifiable, collateral adequacy, and collateral summary. It has given some summary, and both of this output will go to the router agent. So as you can see here in the router agent, uh, not last executed has only one content, but last executed batch will have two content, because it will collect both the outputs, market risk agent and collateral evaluator agent, and its outputs are present here. So that is the content of those two agents, and history is what all agents are done with the output. So now this input will go to the LLM, and LLM will decide something, and basically it decides the this is the input to the next agent. So LLM has decided, and it has given to the fraud signal says nothing, and the financial data shows has strong credit profile and moderate ratio. So sufficient collateral market conditions are favorable, and there's no significant fraud signals detected. However, the recent cash deposits may warrant further review for consistency. So this is the opt of the fraud signal. So it has not detected any fraud signals. So that's why the input directly goes to the next agent, which is a per loan decision agent. So loan decision agent, we have received the input, and the output it generates is loan is approved, and loan amount is the SDK. Interest rate is 5.2. So based on those interest rate also might vary for different persons. So those things we are not trained for the LLM. So if in case we want to train it, we can train it saying that, hey, if this is the LTV, what should be the interest rate? That kind of thing, we can do it. So this is the output of the agent. Now it will be sent back to the router agent, and router agent is correcting it got the input, and it will pass on to the output. So output has been generated here in whatever the output data we have. I just put it the JSON. So we have a collateral evaluator output, financial profile output, loan decision output, and market risk agent. So the loan decision output is the final one. It's the approved one. That's what we have seen in the agent output. So let me just clean up this, so that let me run another branch of the flow. So I'm just commenting the previous portion, and I'm just enabling the workflow input that I wanted. Let me just refresh it. Yes, I have commented this particular portion where it was not going to the workflow branch. So now what I've made changes is I'm asking for a bigger loan amount, and also have reduced the residential property to 200K instead of 1000K, and just reduced to 200K. So that's some sort of a flag it can create, because we are asking for 1250K, and your property is just 200K worth, and I just want it to go to the sub workflow. So let me just rerun this workflow input. So let me refresh it. So rest remains the same. So only thing my interest was in collateral. So let me just show you the collateral input output. So it's the collateral financial profile and the collateral. So this is the input, and what collateral identifies is sort of a residential property. LTV ratio is 6.25. Basically, just dividing the loan amount asked and the current market value of the residential property. So it has found to be 625. So it is a liquidity is high, verifiable, inadequate, collateral adequacy is inadequate. So this will flag the our router agent. Let us see what router agent does. Yes, so the router agent has decided that there's a fraud. So let us see where it is. Input agent last executed. So these are the market risk and collateral. So this is the input, output, router agent, collateral. So low favorable, sorry, collateral is here. It's inadequate, it is semi-inadequate, and there is a fraud signal here. So grossly insufficient collateral for loan size. So a fraud signal is detected. So it means it has to go to the next agent. The next agent is is the input agent. Workflow loan risk router towards to workflow fraud investigation production. So this will be the next agent it calls. So it has gone to the next agent now. The next agent is basically the workflow. So let us see the workflow. So workflow, the first agent is a workflow transaction history. So it gets the input. It gets all the input, fraud signals, financial collateral, all the details it gets. It collects the output. It gives it back to the next agent. So let us show the output of this transaction history. So transaction history is saying consistency, visual pattern. There are 3 large cash deposits totaling to 95 in last 60 days and high risk transaction. So it thinks that as a high risk transaction. It gives to the next agent. The next agent is a identity verification. So we are not connected anything to the identity verification. We could have given some input like other details of the users for identity verification, but we are not given it. And the final is a fraud score. So basically the fraud score will generate some score on pivoting factor, 65% fraud score, grossly insufficient collateral to own size, large cash deposit, moderate identity risk. So it has given the fraud verdict. It's the suspicious, and this will be sent back to the our root agent. So this is this is the last node is our investigation workflow, and last executed is we have a output of investigation workflow, and again in this we have three keys for other sub workflows agents. So those details are present here. So this is the input coming, and then it takes it sends it to the loan decision agent, and with all the details, financial market risk, collateral, and fraud investigation. So in previously when we were testing without the fraud investigation, this key was not there. Now we are given this key. In that I get 3 sub keys. All the contents are present. Other sub agents outputs are present here. Now it will receive and it will decide things. So let us see the output of the risk. So rejected, loan amount is not given. If it is accepted, loan amount will come. So interest rate is not required. Rejection reason, collateral is inadequate and insufficient to cover the requested loan amount. LTV ratio is extremely low. So that's the reason it has given. So this comes back as an output, and that will be sent to the user. So you can just copy paste this content. It's a very big content. So you can just copy paste it in JSON. The same content, whatever we are seeing here, right? So that will be shortly. So this way we have implemented workflow within workflow or a nested workflow or a multi-level workflow, where we have shown you how to create a router which will take a call to which agents to call subsequently, and to make one agent itself as an graph creation guy. So we need to give a type as dynamic, and you need to select that node ID, and that node ID which is having an passcode to route all subsequent individual agents. So this way we can create a multiple workflows or a hierarchical workflow. So in next video we'll show you the example of that we shown during the hierarchical pattern. So we'll use that hierarchical pattern and we'll use the workflow concept, and we'll create a another example for showcasing you the workflow details. So once if not required, you can remove the workflows. So let me just remove this workflow, and let me unregister the workflow as well, and we can remove the agents that we have registered, and we can unregister the agents. So remove agents will remove all the agents, and remove unregistered agents will unregister the agents. So let me just show you the pod details, whether they are present or not. So let me show you the workflow pod. It must be in terminating. This is in terminating state. And to check the pods, let me just show you the So those pods are in terminating. So all those pods are off. So this is the complete notebook tutorial for you to run your multiple workflows. So you can curate this example. You can modify this example according to your need. Thank you. Thanks for watching and keep supporting us. Thank you.